I want to discuss few things about LearnCpd's given graph. So in this part of the assignment, you would be putting everything that you've done together here. So if you look at this function, so you have a data set which is your examples. Then you have your G graph, and then you are given the true labels. So those are the inputs. And what you're supposed to do, you're supposed to return the parameterizations, and which is the P, and then the log likelihood. So coming to this P, remember you already implemented the fit Gaussian parameters and fit linear Gaussian parameters. So you would be using those two that will help you in populating the parameters in the P. Now, when you're populating these parameters, one thing you want to keep in mind is you want to look in your graph and make sure you have to apply certain parameterization when you're dealing with a parent, and certain parameterization when you're not dealing with a parent. So specifically, basically, if it's a parent, we are going to use the fit Gaussian parameter, and if it is not a parent and if it is a child example, so we are going to use the fit linear Gaussian parameters. Now, one thing I did find useful, or at least in my implementation, I hope this is not some violation of honor code because I'm just only going to share the signatures. I wrote two helper method, which is get parent part. So for a given child part G and the actual class, it will return the parent part for that child part. So that's one function I wrote. The other function I wrote is get part examples. So if you are given a particular part, for example, like the child part, data set, K, and labels, it will return all the examples of that particular child part, for example. Now again, as mentioned in the documentation, in the PDF, reshape would be useful in implementing this get part examples. Again, you can implement the way you want. I'm just trying to share how I implemented it. If you like it, you can, I guess you can try to do something similar. If not, you can do it in your own way. Now, you might be wondering, okay, why do I have this get parent part? So remember, when you are dealing with this fit linear Gaussian parameters, you have this x and u, right? So this u is so for a given child part, okay? So you have examples of the child part, that's your x. You also need to have those parents, right? So that's why you have this. That's why I have this get parent part. Okay, so that will help you for the second argument of the fit linear Gaussian parameters. And obviously, this is basically just looking. You take a part and then you look in data set and you return examples of that type of part. That's what that second get part examples is. All right. So and then once you find all these parameters, you would populate your P, and then eventually when you're all done, you have your P, you have your so you have your P, you have your G, and you have the data set, and all you have to do is just call this compute log likelihood that you have already implemented. So that's what this learn CPD's given graph is all about. So one more time, quick summary. So basically you will look in G, you will find if it is a parent. If it is a parent, obviously you would use this fit Gaussian parameters. And if it is a child part, you would be using this fit linear Gaussian parameters. And when you're actually implementing calculating these parameters, you need examples. So for that, and also in case of child part, you would also need the parent part. So for that, in my implementation at least, I had this get parent part and get part examples from the data set for a certain type of part. You could use reshape to get these examples and calculate your parameterization. And in the end, after you're all done, you would just use compute log likelihood that you've already implemented. Good luck and thank you.